This lesson is about ratios and proportions. The objective is to write ratios and to solve proportions. So what is a ratio? A ratio is a comparison of two quantities by division. It can be written in three different ways. A ratio between A and B, where B is not equal to 0, could be written as a fraction. It's probably the most common form that we see. Could be written with a colon, two dots in between the A and the B. And it could just be written with the word to, A to B, written in the middle of the two quantities. So those are the three common ways of writing a ratio. An extended ratio compares three or more numbers, such as A to B to C, with colons in between. An equation that states that two ratios are equal is called a proportion. So if I have A over B equals C over D, that is a proportion because I have two ratios that are set equal to each other. The first and last numbers in a proportion are called the extremes, and the middle two numbers in a proportion are called the means. Now, you've probably had ratios and proportions for several years now in math, but you may not have had that terminology used. So the extremes, if we look at these ratios as A to B is equal to C to D with a colon in between, then when it says the first and last numbers in a proportion, it's talking about the A and the D. Those are the extremes. And the middle two numbers, the B and the C, that's what it's referring to as the means. So if we look at this as in another form, as a fraction equal to a fraction, A over B equals C over D. If we look at it in that form, then the A and the D are in these locations. It's the numerator of the fraction on the left and the denominator of the fraction on the right. And then the other two numbers, the B and the C, those are going to be the means. Okay? So that's the two different ways of looking at a proportion and writing a proportion and the location of the extremes and the means in each one. So now let's look at some properties of proportions. The cross product property, once again, you should have already been using this for quite some time in algebra and in math. But what it states is that in a proportion, the product of the extremes equals the product of the means. So what that means is if A over B is equal to C over D, where B is not equal to 0 and D is not equal to 0, then I'm going to take the product of the extremes, A times D, and that is going to equal the product of the means, which is B times C. There are three other properties of proportions below that we will look at here, and in all of these properties, note that none of these values, A, B, C, or D, do not equal 0 for these properties to hold true. In the first property, it gives a proportion A over B equals C over D is equivalent to B over A equals D over C. So what did we do in this property? This property, you simply take the reciprocal of both sides. So we'll call this one the reciprocal property. Of proportions. And in property 2, A over B equals C over D is going to be equivalent to A over C equals B over D. So what did we do in this particular one? This one took the values that were in the means positions and switched them. So here we're just going to say that we're going to, this is the property that allows you to switch the means. Note that it's also valid to go from the original proportion, A over B equals C over D, and you can also switch the extremes, and that's also valid as well. So let's also put that one there. If I can take the A and the D and switch them, so I'm going to put the D and the A, I'm going to switch those and leave the B and the C. So I can also switch the extremes, and that's also going to be a true proportion if I switch those extremes. And why is that? If that's true, because the cross products are still going to be the same whether they're switched or not. So that's why that property is true. The last one of these, A over B equals C over D, is equivalent to A plus B over B and C plus D over D. So all that we're doing in this property is you add each denominator to each numerator. So my original denominator in the original proportion was B, so I had A over B on the left, and I just added B to the numerator. And on the right side it has C over D. D is the denominator. I just added D to that numerator. So that is a valid proportion property as well. So let's look at some examples on the right side. In example 1 is using ratios. It says a pygmy rattlesnake has an average length of 18 inches, while a western diamondback rattlesnake averages a length of 5 foot 6 inches. What is the ratio of the length of the pygmy rattlesnake to the length of the western diamondback rattlesnake? So one thing, property of proportions, you need to keep in mind is that they need, when you're talking about units of measurement, you need to have them in the same units of measurement while you're comparing them. So we need to convert the 5 foot 6 inches into inches so that we're comparing inches to inches. So 5 feet is 5 times 12, which is 60 inches plus 6 inches. That's going to be 66 inches. So now we can compare these because we're talking inches to inches. Now we have 18 inches that's compared to the 66 inches, which that's like a fraction. You could also have said it was 18 over 66. Okay? And we need to reduce that. And to reduce that, you reduce that just like you're reducing any fraction. 6 will go into each of these numbers. So 6 will go into 18 3 times, and 6 will go into 66 11 times. So we have 3 to 11 or 3 over 11 as the correct ratio. On the second problem of using ratios, the measures of two complementary angles are in the ratio of 1 to 3. Remember that complementary angles are two angles whose sum is 90. and it wants to know the measure of each angle. So anytime you have numbers in a ratio, you can express this as 1x and 3x. So if we're going to, these are two angles, and then we need these to add together to be 90 since they're complementary angles. So 4x is 90, solve that. So x is equal to 22.5. So that's our first angle. And then the second angle is going to be 3x. The 3x is equal to 3 times 22.5, which is going to be 67.5 degrees. So that's the measure of the two angles. Problem 3 is using extended ratios. The lengths of the sides of a triangle are the extended ratio 2 to 4 to 5. The perimeter of the triangle is 77 inches. So what is the length of the longest side? So perimeter is measurement around the triangle. So we need to add the sides together. So if your ratio is in the form of 2 to 4 to 5, let's just once again make that a 2x, a 4x, and a 5x in order to calculate that. So we have 2x plus 4x plus 5x is 77. So that's 11x is 77, and x is equal to 7. And it wants the length of the longest side. The longest side is going to be the one in the extended ratio with 5, or 5x. So 5 times 7 is 35 inches. It's going to be the length of the longest side. Problem 4 is using the cross products property. So to use the cross products property, that's the first one, A, you have 3/8 is equal to 5 over x. We're going to take the product of the extremes, which is 3 times x, and that's going to equal the product of the means, which is 8 times 5. So if we look at that, we're going to have 3x is equal to 40, and x is equal to 40/3. The B problem is the same type problem, only here you're going to have to use the distributive property. When you multiply, you're going to have 6 times y plus 3 is equal to the 12 times the 5. So on this one, you're going to have to use the distributive property, and you got 6y plus 18 is 60. Subtract the 18 from both sides. 6y is 42, and y is equal to 7. In problem 5, you're using the properties of proportions that are over on the left. In the diagram, it indicates that x over 10 is equal to y over 9 is your proportion. So the question is, what ratio completes the equivalent proportion y over x over y is equal to what two numbers on the right side? And you need to use one of the properties of proportions over on the left. So what have they done? The y has moved down to the position where the 10 is. So the x is still in the same position. So that means that they have used the property to switch the means. So the x over y is going to equal to 10 over 9 is the equivalent proportion that they're after.